Anup sir,
Ma'am,
I will send it in a HOD mail.
okay, ma'am, send it.
That file name is TF6G.
Okay. For the participants, just in 2 minutes, we'll start the program.
Yeah, Anup sir, just check no. Yes, Anup sir, tell me. Hello? Yeah.
Hello, sir.
Can you switch on the PPT mode, no?
PPT mode just it's coming on your screen. Now just I'm switching on, sir.
Yes.
Full screen has come, na, ma'am, sir.
No, no, no.
Hello.
Dr. Vanisri, madam, should I?
Yes, sir. Yes, sir. You can start now, sir.
Yeah, then so good evening to
Sir,
one and all. And
one request, please switch on your camera, sir.
yes. Hello,
Yes, sir.
should I go ahead?
Yeah, yes, you can start now.
Yeah. Good evening, one and all.
Good evening,
So
sir.
then today I would like to share about the it's an overview of 5G and 6G. And the difficult situation is that 5G we are not fully realized and not fully implemented, and 6G that just started. So my presentation is just overview, develop the awareness. So anybody wish to join for the 6G research, but the right time to join for 6G research. So it will give some information about what is going on and where we are and what is the status. All insight you will get there. A brief information about various activities of 5G and continue the 6G. Let us go to next slide. Anu?
Hello.
Yeah, then my presentation flow will be like this. First, we are talking about the evolution of the wireless technology, then overview of the wireless communication networks, advanced 5G wireless communication, and later going key enabling technologies and disadvantages of the 5G. Then next, go to the technology enables and the 6G capabilities, and later 6G network evaluations and feature scopes and research and advantage of 6G networks. And now finally, I'm going to conclude. Next slide. Next slide, please. And if you see I mean, previous slide, can you please go on? Anu? Previous slide. Yeah. If you see that evaluation of wireless technology, 1G, 2G, 3G, 4G, and 5G, particularly if you see that, and 1G talks basic mobility, and then more services, data presence, 2G talks, and 3G objectives for the global radio access, and seamless roaming is the major concern, and 4G talks about IB, the major object IP-based mobility, and 5G for the future upcoming and with the high speed giga speed data we are going to achieve, and particularly 5G 6G is targeting the real-time applications. We'll see that what it is. Let's go to the next slide. Next slide, please. And 1980s, our generations started, and particularly first we are talking about the analog communications, analog voice. We are going to do in the first G. Next second is 2G, the talks of digital voice, and GSM. We have noticed we have enjoyed GSM network we used, and later we shifted to the mobile data. And 4G is the focus on the mobile broadband LTE, and we have the long-term evaluations. We have seen that gigabit LTE also. Then now we are working on the 5G with the edge computing and wireless edge. Let us go to next slide. And particularly if you see the generations are why it is moving nothing but increased number of devices, because particularly IoT introduced. So we need a compatible and suitable generations wireless networks. And next the increased carrier frequencies. And if you see that advanced access schemes and increased and reliability and reduced latency, all this is the main factors for the going for the new generations. Next slide. And of course, advanced 5G wireless communication applications, if you could see, particularly this massive mission type communication application, is mainly for the mobile devices and networking. The features are Gbps, data rates, extreme capacity, uniformity, deep awareness you can expect, and ultra reliable low latency communication is almost maybe 1 millisecond latency. This targeting for the wearable devices and smart cities and smart homes, and enhanced mobile broadband is particularly for robotics, autonomous, and healthcare. All these things is the and customized 5G network is supporting. Next. And
Camera.
in generic 5G architecture is, if you see that a macro cell comprises of several small cells, and finally you can see that NFC based cloud is where interfacing, and then later here the internet protocol we are connecting, finally applications we are interfacing. These are basic generic architecture of 5G, and it starts with a small cell and which comprises of the micro cell having so many small cells interfacing with the and function virtualization, network function virtualization cloud. And next is the interface with the internet protocol version 6 connect, then application where interface. So this is the architecture for 5G. Next, let us go.
Processor. Switch on the camera, no, sir.
And
Switch on the camera, sir.
regarding to me, you are asking?
Yeah, I'm asking you.
Yeah, okay, right. And so when if you see the data rates, and it is 100 times of the 4G, and latency the 1 millisecond. That is we have to appreciate the 5G. Energy consumption 10% of 4G we are taking. Cost is 100% cheaper than the 4G spectrum. And device, it will support 3 lakhs devices for access point, and so battery life 10 times of 4G. Reliable 99.9999%. That's what it will support the real-time applications. And let's go to next slide, please. And the advantage we see very briefly, and high speed it will support. It allows user to download movies, videos, and it is seconds. This is the takes hardly seconds to download. Latency reduced to all 1 milliseconds, and increased capacity. We have seen just 100 times more capacity than the 4G, and bandwidth also enhanced, and so that we can go real-time applications and many many devices we can connect it. Less tower congestions, and 4G cell networks have so many often get the congested, which will result in the various problems. This is avoided in the 5G network. Next. And disadvantage also that that's what we are moving to 6G. Limited coverage globally. It has limited global coverage and is available only in the specific locations. Only cities can benefit a lot from the 5G network, and remote areas may not get the better coverage. Setting up the towers are expensive, but the towers is expensive in the 5G implementation. Decrease the broadcast distance, because since you're going high frequency, the distance will be reduced. That is, very well. And it time consuming, and the implementation take the more time consuming and expensive, because we are going to establish the towers. So uploading of the speed, which is mobile phone user to ensure super high speed, you can upload it. But while other than that, upload speeds are more than 100 Mbps when compared to 4G. So then battery issues are there, because since you develop so many applications, therefore use battery drain that reduces the lifespan to a large extent, and manufacturer need to invest in a new battery technologies. Security is still problem in the 4G. They are not focused in 5G, and 6G they focus more on the security issues. Is one of the drawbacks of the 5G, because it will result in a hacking. The expansion in the bandwidth enables criminals to steal the database. Moreover, it uses software that leads to the vulnerable attacks. If 5G connect the more devices, the chances of attacks are more. Next. And technology enables, if you see for Gen 6G, is the technologies supporting deep learning and terahertz human chip implants, distributed network communication, optical wireless communication, intelligent reflective surfaces, IRS. And 5G is the advanced applications. If you see enhanced mobile broadband, massive mission type communication, ultra reliable. We have seen that ultra reliable low latency communication, that is for the medical application, cloud computing, and SDN software defined networks also, and 4G for the MIMO antennas, and YFDMA improved modulation coding voice over IP, and high speed internet we have seen in the 3G, IP technology, and digital wires. And next slide, please. And differences between the 5G and 6G network, let us see that what we are going to target in the 6G. And faster than the 5G technology, that we have seen that is 1,000 gigabytes per second air latency. So we're going to achieve 100 times faster than the 5G in the 6G. 6G is the widely believed to be smarter, faster, and more efficient than the 5G, because latencies are very, reduced latency. If you compare the 5G, low latency 5G network, 4G network has latency about the 50 milliseconds, and whereas the 5G network has 10 times lower latency than the 4G, and 5 milliseconds. 6G is the latency slip down to the milliseconds. So that the 5 milliseconds will come down to microseconds or milliseconds. That is useful for the real-time applications. And of course, another fundamental difference, 6G technology will be the use of millimeter waves, which is expected to lead to the possibly noteworthy breakthroughs in the wireless sensing technologies. Next slide. And key performance indicators, if you see that data rates are 20 Gbps and 100, there's a 5 times we are getting, and 1 terabytes. And latency is the 1 millisecond, is the 1 microsecond roughly around. Density, 1 device per cubic meter, 10 devices per the 1 means 10 times. And if you see that artificial intelligence machine learning is a probable, is a yes in case of this one. And so many other advantages. You see that 6G. Next. And characteristics of 6G, if you see that 6 normally key technology of 6G, and if the new spectrum technologies and AI native air interface, networks as a sensor, there's a very, appreciable this one network as sensor. There's a one advanced feature of the 6G, extreme connectivity, cognitive, automated, and specialized architecture, and security and trust. These are the major focus of this 6G. Next. And let us see brief about all these characteristics. Artificial intelligence and machine learning over the past 10 years, AML techniques, particularly deep learning, have grown quickly and are now being used in a very variety of image characterization of computer vision related field, and social network to security by eliminating complexity and letting AML figure out the optimum way to communicate between the two endpoints. And spectrum bands is the radio connectivity lives heavily on the spectrum, and new pioneer spectrum that aids the maximizing the advantages for cutting edge technology, since we are going for the new spectrum network that can sense. This is a very important feature of the 6G, the ability of the 6G to sense the environment. That is a very important feature of the 6G. If anybody wish to focus, they can focus on that. And the ability of 6G to sense the environment, people, and objectives would be its most prominent feature, by collecting the signal that are reflecting of objects and identifying their type, shape, relative location, like something like radar technology, velocity, and possibly even radar features, even material qualities. The network transform into a source of situational information. So you can get the environment information also. You can sense that what is there. Combining this data with AML, the network will become more intelligent and often fresh perspective from the physical world. So ultimately, AML is going to add the value addition to the data. Next. And extreme connectivity. In order to meet the most stringent connectivity requirement, connectivity is very important. We are daily facing, sometimes when you're talking, we are call drop, we have seen that the connectivity plays very important role for successful call, and including some millisecond latency, the ultra reliable low latency communication services introduced with the 5G will be improved and developed in 6G. Simultaneous transmission, several wireless ops, device to device connections, and AML could all increase the network stability. The experience of real-time video communication, holographic experiences, or even digital twin models, and updated in real time through the deployment of video sensors will be improved by enhancing mobile broadband coupled with a low latency and enhanced reliability. Low latency is very important. Networks sub have sub networks with unique requirement, forming networks of networks with the networks as an endpoint. A body area network, which plays important role in the hopping, particularly car area network, CAN and WAN. For example, can have hundreds of sensors deployed access across the area less than 100 meters for the mission system is operated. These sensors must communicate with 100 microseconds and with extremely high reliability, making networks with the cars and robots truly wireless will open a new era for the designers of those devices as they would no longer need to install lengthy and bulky cables for systems. And new network architecture, 5G is the first system designed to operate in the enterprise and industrial environment, replacing wide connectivity industrial. Industries will need ever more sophisticated designs that can allow greater flexibility. Flexibility plays very important role in industrial systems. Security and trust plays important role. Cyber attacks are increasingly targeting different kinds of networks. Strong security method must be implemented due to the threat's dynamic nature. The 6G networks will be made to be resistant to dangers like jamming when developing a new mixed reality environment that include a digital representations of actual and imaginary objects. Privacy concern must be taken into account. So security plays important role in the 6G research. Next. And you're seeing that the ban and WAN, how the network has been implemented. I mean, a small example for you. There's so many sensors are, like wearable sensors, and so many sensors are there in the, cars. So the car can act as one of the trans receivers. So that will be possible in the 6G. 6G research. They are going to focus on that next. And key enabling technologies for the 6G network, if you see, we have seen the 5G, now we are seeing the 6G and beamforming, ultra MIMOs, and reconfigurable intelligent surfaces. IRS is playing important role, AML and millimeter waves, the satellite communication, and 3D is the possible in the 6G because you can use the, satellite communication, terahertz waves and quantum communication. All this we'll see in the next slides. And let us go to next. And the global organization working, what are the companies are working on? The brief information about 6G because just started 6G research. So SK Telecom, a South Korean telecom organization, has signed agreements with Ericsson, Samsung, and SK Telecom and South Korean Telecom both are working. Again, the Samsung and Nokia also, they conduct research and development 6G mobile network technology jointly. And so there is the terahertz test equipment manufacturing organization recently supported with the 191 million funds from the Sustainable Innovation Fund with Innovate UK, an innovation agency based in the United Kingdom. This is considered to be a crucial step forward for the making for 6G reality. With a focus on using its expertise and intellectual property, Teravi will help in building the blocks for the future 6G network and accelerate its development. And Google also, one of the main players in 6G research, Google and Apple, have expressed their interest in 6G research and joined the Next G alliance that was built in the October 2020 to create a 6G roadmap and motivate North American companies to prepare themselves and be at the forefront of the adopting 6G across the globe. And Korean companies also actively involved in that. Korean MNC LG Electronics has stepped up to develop 6G technology with the established research center. Company's CTO part 2 and monitor to the support R&D for the next generation 6G network and led to the role with the global standardization and creation of new business opportunities. So more or less, and all the top companies, top countries are involved in the research. Next, let us go next slide. And this is how these evaluations. If you see that 6G evaluation and will vision, invention, proof of concept, standardization, commercialization. Let us see each and everything in the next slide. And the wheel starts with a vision of the certain scenarios, applications, catering the problems and needs and the requirement. Then companies start doing the research to find and patent different inventions of fulfilling those requirements and make models to test it. Everything, every innovation starts with the vision. That's what is generations are started. Afterward, the standardization effort starts where the industry leaders collaborate to define standards that the device must compile with in order to meet the requirements set in the vision stage and interoperate with the device of each other. So standards will be set by the industries. So vision moves with the standards. In the wheel of evolution, 6G is a pretty early stage because 6G just started and no technology has been invented yet to cater the requirement set of the 6G standard. So 6G standard not yet defined. So this corresponds to vision stage because still 6G is a vision stage only. We are not, still not progressed. Still we are in vision stage where your problems are needs identified and all the requirements are established. The next stage would be the invention stage. So then at invention stage, still we are in the vision stage. 6G right now is at the vision stage and moving toward the invention stage. However, while many operators are yet to introduce 5G network, developers have already started active research on 6G. So the main observation here is that 5G fully we are not realized, but we are working the 6G research that we have to appreciate. So in fact, the University of recently one big conference conducted by the Finland University and 6G flagship event. There are some conclusions. They derived from the participants. Then the various presentations. Let us see what are the conclusions. Next slide. Yes. Next slide, please. The concept of semantic communication, the connectivity and network are more efficient is an important emerging area of the research, which is closely connected to the semantic AI. Semantic communication plays important role in 6G. The connectivity and networking is very important for the successful networking and is complemented with the semantic AI. Autonomous vehicles are made possible by advances in the wireless networks and in distributed AI and sensing. Each vehicle in a future network will be equipped with the many sensors, including cameras, laser scanners, and terahertz arrays for the 3D imaging, odometry, and inertial measurement units. It is believed that to make the 6G acceptable to society, the protection of private information will be key enabler. That's what the security is very important. So if you are not for a secure network, then nobody will appreciate. That's what the protection of private information will be key enabler to realize full potential. The secrecy is ensured through the quantum mechanics. That's why quantum mechanics is also one of the important technology enabler for the 6G instead of the complex computations. Furthermore, authentication by a physical layer signature, such as RF fingerprinting and some other technology, such as the randomizing of MIMO transformation coefficients, coding, could potentially be used in 6G. So everywhere the security authentications are, they are going to include in that. In addition to the terrestrial network infrastructure based on satellite and unmanned aerial vehicles will be needed to support the and coverage and capacity requirement. Next. This year seen a lot of challenge of 6G, architectural challenges and technological challenges and social challenges. What is the architectural challenges? We have to look into the low latency and AI functions and service-based architecture. We have to work on the network. 100% coverage is important. And if you see the technological challenges, area expansion and frequency expansions and sensing and positioning and charging and power supply that plays important role. Social challenges, you've seen that maximizing the radio user efficiency, frequency utilization, network security also important, net zero and resiliency, redundancy, recovery, all these are important. Let us see next slide, brief information about all this. Next slide, please. Challenge of 6G is if you see that the demand for the breakthrough technology advancement, demand for a breakthrough technological advancement, achieving the ambitious goals of 6G such as unprecedented speeds of 100 gigabits per second and ultra low latency of 1 milliseconds or less. and massive connectivity of up to 100 billion devices, because IoT is coming up, it is supported by the 5G and 6G. Therefore, 100 billion devices. So necessitates significant innovations in hardware, software, and network architecture. Overcoming these hurdles requires the collaboration of experts across various disciplines. So, various experts should involve in the 6G designs and pushing the boundaries of what is currently possible. Spectrum allocation. The spectrum, a finite resource for the wireless communication, is becoming increasingly crowded as existing generations of wireless technology coexist. To accommodate the exponential growth in the data traffic and the device needs of 6G application, new spectrum bands must be identified and managed efficiently. The international, the ITU, the 32-300 gigahertz frequency band is a potential candidate for 6G. However, this band is also used by other wireless technologies such as the millimeter waves 5G, which could lead to the spectrum congestions. And next, and security. As connectivity expands and critical systems become increasingly reliant on wireless network, ensuring robust security measures becomes paramount, with the potential for billions of connected devices, safeguarding data privacy, preventing cyber attacks, and establishing trust in the network infrastructure become formidable challenges. The National Security Agency has warned the 6G could be vulnerable to quantum computing attacks. Because already 6G we are not realized at all. Already there are warning from the National Security Agency. You have to realize about this one. You have to observe that, because 6G is still in the vision stage, but still there are a lot of warnings we are getting when we are using the quantum computing, etc. So you should be careful about all these interfaces. Socioeconomic challenges. The global deployment of 6G faces socioeconomic challenges, bridging the digital divide, ensuring equitable access to advanced connectivity, and managing the potential disruptions to existing industries and job market are crucial consideration. The World Economic Forum estimates the 6G could create up to 20 million new jobs. This is a good news for us, because create the new jobs in 2030. So that is, we have to appreciate the 6G technology. 20 million new jobs means we have to appreciate. And interoperability and standardization. Diversity technologies, application devices converge with the 6G ecosystem. Establishing common standards and protocols becomes paramount. Collaboration among the industry players, standardization bodies, and regulation agencies is necessary to ensure seamless interoperability, enabling the widespread adoption of 6G technologies and applications. Timeline for 6G, it is important to note that the development and deployment of 6G will occur through the multiple phases, each building upon the success and lessons learned from the previous wireless gen. So there are no specific timeline. So it is depends on various factors. It depends on deployment and success stories and lessons. Again, proceeding further. All these things is the unpredictable timeline. Next slide. And 6G working, very briefly, we'll see that how it is working and major principles and in that. And ultra high frequency data transmission is a major focus for 6G research. First, 6G researchers are working to figure out how to transfer data using waves in the terahertz, hundreds of gigahertz range. Although these waves are require small and delicate and vast quantity of unoccupied spectrum in upper atmosphere would permit amazing data speeds. Lack of suitable semiconductor material that can operate the several, terahertz. It might need massive arrays of tiny antennas to get any range of out of these frequencies. Researchers will need to create models that allow data to go via extremely convolved paths in order to overcome the effects of water vapor in the environment, which scatter and reflect the terahertz signals. Current wireless system only let you transmit, receive, and an given frequency at once. You can partition your channels by frequency division, FDD and TDD, to enable the two-way communication. Finding a solution to simultaneously send and receive a same frequency using extremely complex calculation with the efficiency of the available spectrum by 2 times. So that is possible in 6G network. Next. And 5G is still primarily a hub and spoke system in which the end user devices connected to the base station. This is a basic 5G network architecture that connect to the backbone of backbone. 6G will allow gadgets to act as a data boosters. This is important point. In the 6G, the gadgets should boost the data distance and data boosters for the one another, allowing each device to both use and extend the coverage. So, and ultimately, device should work as a booster for the, extending the range and coverage. And speed computing is one of the one more feature is a 5G innovation, but 6G might make it much more effective. And what is speed computing? You know very well. Data transfer speed between the devices is referred to as latence. The lower the latence, the more your mobile phone can rely on the speed computing, in which some data is processed locally and some is processed elsewhere and transmitted. This is about the speed computing. This is the crucial for the application that provide your device a continuous stream of the sophisticated information. The goal of 6G is achieve latency below 1 milliseconds, which will call for the a ton of other technology advancements. New version of the internet protocol may also be necessary. The internet structure as a whole would change as a result. The current IP packet as being like a first class letter with an addressed envelope and some sheets are text. A new IP packet would be the FedEx package. So normally we are comparing with the 5G IP where with the envelope and 6G we are new protocol is we are calling as a FedEx package, which accommodate more devices, more connectivity. Mesh networking solve issues brought on terahertz signals, limited range. Of course, this we know. Let us go to next. And 6G will have big influence for the many government and because 6G is focusing on the security issues. Therefore, it support the government requirements. Once the secure networks, government will favor and to adapting for those various activities. And that is the public safety and critical asset protection, such as the following: threat detection, health monitoring, feature and facial recognition, decision-making areas like the enforcement and social credit systems, air quality measurements, gas and taxity sensing, sensory interfaces that feel like real life. Improvement in these areas will also benefit smartphone and other mobile network and emerging technologies such as the smart cities, autonomous vehicles, and virtual reality and augmented reality. All these things are possible with 6G. Next. And let us see 6G architecture, how it looks briefly. Expected architecture only, and this is not at final. The deployment of services has evolved from the dedicated server hardware to the virtualization and cloud infrastructure. The core network and the management plane with the service-based management architecture, the end-to-end service-based architecture. And it continued to rely on the specialized hardware running logically distinct radio access network. Ultimately, service-based architecture rely on the core network and the RAN. 6G, it is anticipated that the SBA service-based architecture will be able to extend throughput the entire network across all planes and from end to end, including the core network and RAN and terminal. This will enable much greater operational and deployment flexibility, support network of network concept, and make subsystem integration and scalability easier. So ultimately, service-based provide the scalability easier. Next. And necessity, why we are going 6G, the technology convergence, the sixth generation of cellular network will integrate previously disparate technologies such as deep learning and big data analytics. Edge computing, the need to deploy edge computing to ensure overall throughput and low latency for the ultra reliable, low latency communication solution is an important driver for the 6G. Internet of Things, another driving force is the need to support. That's what I told. Internet of Things support demands for the more connectivity, more more systems in more device interface. So therefore, we need the 6G, and it demands for 6G implementation. High performance computing, a strong relationship has been identified between 6G and HPC, high performance computing. While edge computing resources will handle some of the IoT and mobile technology data, much of it will require more centralized HPC resources to do the processing. Next. In addition to the surpassing the 5G, 6G will have a range of unique features to establish next generation wireless communication networks for linked devices by using the machine learning and artificial intelligence. This will also benefit emerging technology like the smart cities, driverless cars, virtual reality, augmented reality, in addition to smartphone and mobile network users. It will combine and correlate different technology like deep learning with the big data analytics. A substantial correlation between 6G and high performance computing has been observed. While some IoT and mobile data may be processed by edge computing resources, the bulk of it will require much more centralized HPC capacity, making 6G an essential component. Next. And of course, this is a brief summary of the terahertz per second speed and AI core networking. This is microsecond latency, AI core network management, industry standards, and short range communication. Next. And see what the feature scope, what the research involves, something like the term before 4G lasted for a while. It referred to what could be possible beyond the 4G. Ironically, the LTE standard is still evolving and 5G will use some aspect of it. And similar to before 4G, beyond 5G is seen as a path to the 6G technology that will regenerate capabilities and applications. 5G may private wireless communication implementation involving LTE, 5G edge computing for enterprise industrial customers have helped put the groundwork for the 6G, because beyond 5G is helpful for the 6G implementation. And next generation 6G wireless network, they will create a web of communication providers, many of them self-providers, much in the way that photovoltaic solar power has brought out cogeneration within the smart grid. 6G could advance mesh networks from the concept to the deployment, helping the extended coverage beyond the range of the order of cell towers. Data centers, you know very well, are already faced with the 5G driven changes. These include the virtualization, programmable network, edge computing, and issues surrounding simultaneous support for public and private network. Some business customers may want to combine on-premise RAN with hybrid on-premises hosting computing, edge computing, core computing, respectively, data centers. All these things is possible in the 6G. Next. Uh, And if you see the unique features, the use of the new spectrum band. Spectrum is an essential component of radio connections. Every new generation mobile device requires the pioneer spectrum to fully leverage the advantage of any further technological advancement. And for urban outdoor cells, and you have seen the 7 to 20 gigahertz, because this will be segregated for the requirement. Next. And very high data transfer speeds, we have seen that. And 6G supports 5G is scheduled for the offer peak data throughput of 20 gigabits per second and user experience data rates of 100 megabits per second. Our 6G is the 1 terabyte and it is 1 Gbps. So user experience, the realization of the 1 Gbps actually the 1 Tbps. These are variations you could see. High spectral efficiency will offer many user instantaneous access to the modern multimedia services and must redesign their current infrastructure framework to enable the higher spectral efficiency. Ultra low latency network functions. The latency of 5G will lower to just for 1 millisecond, and many real-time applications performance will be enhanced by the ultra low latency. That your healthcare application, numerous delays sensitive related application will have the better performance and functionality to this drastic reduction in the latency. Additionally, decreased latency will allow emergency response, remote surgical procedures, and industrial automation. Then next. And greater support for the mission to mission is one more unique features. With 5G address both human users and Internet of Things use cases, 6G will focus more on M2M. So 5G you are seeing the human and mission interface, and in case of 6G, mission to mission communication. Today's 4G networks support the 1 lakh devices per square kilometer. 5G support the enabling connectivity 1 million devices per square kilometer. 6G will support 10 times 10 million linked devices per square. That is the beauty of the 6G. All 6G networks will include the mobile edge computing. Although it must be added to the current 5G network by the time 6G network are implemented, edge and core computing will be increasingly assimilated as elements of unified communication and computer infra. Core computing also playing very important in 6G, and a focus on energy efficient 6G network will require stronger radio frequencies to meet the requirement greater bandwidth. However, one of the challenges is the fundamental chip technology cannot function energy efficient in these frequency ranges. Therefore, optimizing the power consumption will be key focus on the 6G developers. So, power consumption optimization plays important role. Next, let us go to next slide. And greater network reliability and the 5G-led ultra reliable low latency communication service will be further developed and enhanced in 6G. Reliability might be enhanced through the simultaneous transmission, numerous wireless hubs, and device-to-device connectivity, and AML consequent 6G will be better than the 5G in terms of the network penetration and stability. In addition, 6G will optimize the MPM interactions by increasing the network dependability by greater than the 100-fold and decreasing the error rates by 10-fold compared to the previous generation. The rise of new architecture 5G represents the first solution designed to replace wide connection in corporate and industrial settings. This deploying service-led architecture in the core foundation and cloud-native deployment, which will be, I mean, radio access network RAN. It is also anticipated the 6G network will be implemented in heterogeneous cloud settings, including the combining of private, public, and hybrid clouds. This is possible in the 6G. The use of AML for optimal connectivity. 5G will allow artificial intelligence and machine learning technologies to achieve their full potential. Even AML will be implemented in various network connections, network levels, network service from the refining beamforming in the radio type and to planning the right self-optimizer network. AML will assist in the achieving superior efficiency in reduced computation complexity. 6G developers such as Nokia, Bell Labs want to adopt the blank slate approach to AML, allowing the AML to determine the optimal method. There's another blank state approach for communication between the two endpoints. Next. Advantages of the network. If you see enforcement security, that's what we are seeing, that security plays important. Cyber attacks are increasingly focusing on network of various types. The sheer unpredictability of these attacks necessitates the implementation of robust security solutions. 6G network will have the safeguard against the threats like jamming. Privacy concern must be addressed when creating new mixed reality environment that include the digital representation of actual and virtual objects. Supports personalization. You can optimize. Open RAN is a fresh and evolving technology that 5G utilizes. However, Open RAN will be mature technology for 6G. The AI-powered RAN will allow operators of mobile towers to provide users with the bespoke network experience based on the real-time user data gathering from the multiple sources. The operators may further exploit real-time users to services where personalized quality experiences and quality services. The operators may customize several services using AI. Once AI is there, it will customization is possible. Extended the capability, the 5G apps, the degree of the bandwidth and responsiveness will enhance the 5G application performance. It will also broaden the spectrum capability to enable the new and innovative wireless networking, cognition, monitoring, and imaging applications using orthogonal frequency division multiplexing. 6G access points will be able to serve several customers at the same time. Next. And drives the development of wireless sensing technology. We have seen this one further discussion. The sampling rate refer to the number of samples obtained from the continuous signal per second as per the equivalent to the time unit to form a digital signal. 6G's frequency will allow for much faster sample rate than the 5G. Additionally, they will provide dramatically increased throughput and data rates. Moreover, the utilization of the sub-millimeter wavelengths lower than 1 millimeter and frequency selectivity is expected to accelerate the advancement of wireless sensing technologies. The network will become a responsive of situational data by collecting signals reflected from the objects and detecting the type, shape, relative position. All these things is possible, and the creation of the mirror, a digital counterpart of the actual environment when combined with AML. This information provides the fresh insights. Earlier slide, we have seen the same information. The further further summarization. Next. And inspiring the new technology innovation. 6G will benefit society as whole since new technology innovations will emerge. Support this includes more advanced data centers, and 6G provides the support more advanced data centers will generate the significantly more data when compared to the 5G network, and computation will evolve to ultimately encompass edge and core platform coordination. As a result of these changes, data in centers will need to develop nano cores that replace traditional processor cores. Nano cores are anticipated to develop as a single computing core that combine the HPC and AI. It is not necessary for the nano core to be tangible network node. Instead, it might consist of the conceptual aggregation computing resources shared by the several networks and systems, and saves cost and reduces software dependency. Operations are already being used by the contemporary networks. Additional 6G components like the media access control, MAC, and physical layers will be virtualized. Currently, physical and MAC solutions require the deployment of specialized network hardware. Virtualization for 6G will lower the cost of the networking environment. Therefore, an immensely ensured dense 6G rollout will become economically viable. Next. And improve the cellular network penetrations. That is, we have seen already among the many advanced 6G network is the vast coverage area. This implies that lesser towers are necessary to cover a given amount of space. This is useful if you want to construct towers where it shows the regular or where trees and vegetation about. Additionally, 6G is intended to support additional mobile connections beyond 5G. This might there will be reduce the interference between the devices, resulting in improved services, optimizing indoor network usage. The majority of cellular traffic today is produced indoor. Cellular networks were never built to properly target indoor coverage. 6G overcome these obstacles using the femtocells, small cells, and distributed antenna systems. Next. And of course, this is you have seen the setting size and generation leaves. And 1G is the voice calling. We have seen 2G is for the SMS, and 3G is for the internet. The speed is also increasing. You have seen that. And 4G data rates also increasing, and Internet of Applications. And 5G is the massive broadband Internet of Things. And 6G, you have seen that emergency efficiency, energy efficient, or artificial intelligence, and new spectrum. Cell-less networks. We are focusing on establish more towers on this. Next slide. Next slide, please. And one of the key breakthroughs offered by 6G is ultra-low latency revolution. Real-time application response time as low as 1 millisecond will enable latency-sensitive use cases such as autonomous vehicles navigating, split seconds precision, virtual reality experiences, and achieving a new level of engagement of remote surgeries being conducted and in real time. This is possible in the 6G applications. Beyond the speed and latency, 6G exceeds the capacity and connectivity in an era driven by the Internet of Things, where billions of the devices are interconnected. 6G can support the unprecedented number of connections simultaneously. And this enhanced capacity ensures the uninterrupted connectivity and paving the way to the seamless interactions between the smart devices, autonomous systems, and intelligent infrastructure, fostering truly in a connected ecosystem. Augmented and virtual reality experiences become indistinguishable from the reality. Industries such as healthcare, gaming, education, entertainment stand to benefit immensely, opening up new frontiers for innovation and interconnections. Next. And 6G become practical. When it's going to practical? And the commercial debut of 6G internet is anticipated to go live around the 2035. 6G flagship initiative combines studies on 6G technology across Europe. Japan is committing and for $482 million to the expansion of 6G in the next few years. The country's overwhelming objectives is to showcase innovative wireless and mobile technology by 2025 in Russia. R&D institution NIR and the Skovia Institute of Science and Technology produced 2021 estimated predictability available 6G network is 20. More or less all countries target 2035. American mobile providers are advancing their individual 6G innovation roadmap. Importantly, AT&T, Verizon, and T-Mobile are spearheading the Next Generation Alliance and industry invitation. In May 2021, the Next Generation Alliance initiated the technical work program develop the 6G technology. So 2035, we're expecting the 6G implementations. Next. And my conclusion is your very brief conclusions and presented a brief overview of the 5G wireless communication. You have seen that brief overview of the wireless communication 5G. And though 6G network is still non-existent and is just in a research phase, and enterprises have started envisaging the state-of-the-art wireless use cases with the 6G technology after successful comparison of the 5G versus 6G network. The main aim is to transition into the new era of the wireless technology and bring in new innovations to transform the world in the upcoming years. Highly exciting possibility with respect to the speed and reliability are anticipated to become a reality soon when the new generation of wireless networks, that is 6G. So speed and reliability is very important, and security also. This new technology is currently certainly going to give new dimension to the way we are living or doing our business virtually today to post-COVID era, making it is hyper-connected world. Next. Next, please. And even as the 5G rollout continues worldwide, leading researchers, consortium, and mobile companies are busy working on the sixth generation of mobile connectivity. 6G network aim to connect the physical and virtual world through the faster MTM communication and better support for the immersive technology. Immersive technology, what is immersive technology? If you see, immersive technology is a rapidly growing field encompassing various types such as virtual reality, augmented reality, mixed reality, and extended reality. There are three key components essential to the immersive technology: hardware, software, and user interface. These three plays important role for the immersive technology. Organizations should know about the working and important 6G network to prepare for the future and fully use of the wireless infrastructure available to them. The advent of 6G are all new era of the connectivity and the transcend of the limitation of its precedents. The advantage of 6G over the 5G is substantial, offering remarkable speed, ultra-low latency, enhanced capacity, and security, and groundbreaking use cases. Next. Of course, this is the resources what I used, and this the last slide is mine. Next. So this is about my last slide. So now we can have interaction. We can have, even doubts and clarification we can have now. And Dr. Vanesri, madam, or Anu?
Yes, sir.
Yeah.
Tell me. Any questions, any queries from any participants? Participant can type and chat box also. Any question from any side? Okay, thank you, sir. Respected Professor Doctor. Topic was really very nice and very informative and also very engaging. We have gained very valuable insights that will surely contribute to our professional growth and understanding of the subject. On the behalf of Electronics and Communication Department, Samskruti College, I would like to extend our heartfelt thanks to our speaker, Dr. Srinivasulu Tadisetti, for sharing knowledge and experience with us. We also appreciate the time and effort you took to prepare for today's session, and despite of the challenges of these virtual settings, this is Google Meet and all. Thank you, sir. Thank you for joining with us and making this session more lively and interesting, sir.
Thank you very much, Dr. Vanasri Madam and Dr. Anup and your Samskruti management for giving the opportunity. I am also thankful to all the participants for the patient hearing and appreciate the kind support. Thank you very much. Yes.
Thank you, sir.
Yes.
Thank you, sir.
For the participants, session 2 of today has been completed. Tomorrow we'll have 2 more sessions, 2 more interesting sessions, and that will start at 6 p.m. So I request you all to join before that and give 100% attendance. Thank you and good night to all the participants. And Dr. Professor Srinivas, thank you again.
Yes.
And good night, sir, to you.
Yes.
Feedback form is feedback link is shared in a chat box. Please participate and fill the form. PPT I will share, madam. After completion of the all section, I will share all the PPTs. Don't worry, madam. Yes, madam.
Yesterday I forgot to fill feedback link, ma'am. Actually, because of my kids, I got some work, ma'am. So
Okay,
how
okay.
that form, ma'am?
Okay.
Yes, ma'am. Ma'am, this which link is, ma'am? ECHOD link or else some LML Lakshmi got some link. Which link I need to fill?
Both are same, madam.
Yeah. Okay, ma'am. Okay, ma'am.
Both are
Thank you.
same.
Yes, ma'am. Thank you, ma'am.
Madam, both links are different, madam.
Both link different. Once I will check it. Once. Wait for some time. Yeah.